Okay, hi everyone, welcome back to this video series on Windows Server 2016. Redundancy in Windows Server 2016. Anytime you're rolling out a new technology, you want to plan that rollout very carefully. Figure out what servers you need, what they need to be placed, and how the networking needs to be configured for those guys. And then once the planning is all said and done, all you need, I want two of everything in case one breaks. We live in a world of always on technology. Services going down is unacceptable, particularly if we are hosting cloud or private cloud services. Really, any application or service that our users depend on to get their private cloud services, really any application or service that our users depend on to get their work done is mission critical and needs 100% uptime or darn close with. The problem with redundancy is that it's much easier to talk the talk than to walk the walk. Maybe someday we will be blessed with a magic press here to make this server redundant button, but that day is not today. We need to understand the technologies that are available to us that enable us to provide redundancy on our systems. This chapter will introduce us to some of those technologies. Since cloud adoption is not mainstream as of yet, we are setting that idea aside for the purpose of this section next. The technologies we will discuss today are the ones that you can utilize in your own local data centers on the real physical or virtual servers that you are responsible for building, configuring, and maintaining yourself. Yes, the cloud can provide us with some magical scalability and redundancy options, but those are easy and we don't even need to know how they work. When we are using our own servers within our own walls, how can we add some increased reliability on our systems? The following are the topics we will cover in this chapter: load balancing, configuring a load balancing website, failover clustering, cluster tier, set up a clustering, failover clustering improvements in Windows Server 2016, network load balancing. Many times I hear people discussing redundancy on their servers. The conversation includes many instances of the word cluster, such as if we set up a cluster to provide redundancy for those servers, our main website is running on a cluster. While it is great that there is some form of resiliency being used on the systems from which these conversations portray, it is often the case that clustering is not actually involved anywhere. When we boil down into the particulars of how their systems are configured, we discover that it is network load balancing, LNB, doing this work for them. We will discuss the real clustering further along this chapter, but I first wanted to start with some common approach to making many services redundant. NLB distributes traffic at the TCP IP level, meaning that the server operating systems themselves are not completely aware of or relying on each other, but the redundancy is being provided at the network layer itself. This can be particularly confusing. NLB versus clustering, because sometimes Microsoft themselves even refer to something as a cluster when in fact it is using NLB to make those connections happen. A prime example is direct access. When you have two or more DA servers together in an array, they are TechNet documents and even places inside the console itself where it is referred to as a cluster, but there is no actual failover clustering going on here, the technology under the hood that is making connections flow on both nodes in actual Windows network load balancing. You've probably heard some of the names in the hardware load balancer market: F5, Cisco, Kempt, Barracuda. These are dedicated boxes that can take traffic headed toward a particular name or destination and split the traffic up smartly between two or more application servers. While this is generally the most robust way you can establish NLB, it is also the most expensive and makes the overall environment more complex. The one feature these guys offer that the built-in Windows network load balancing cannot provide is SSL termination, or SSL offloading, as we often call it. These specialized appliances are capable of receiving website traffic from users' computers, that is SSL, and decrypting the packets before sending them on their way to the appropriate web server. This way, the web server itself is doing less work, since it doesn't have to spend CPU cycles encrypting and decrypting packets. However, today we are not going to talk about hardware load balancing at all, but rather some of the NLB capabilities that are provided right inside Windows Server 2016 itself. Not the same as round-robin DNS. I have discovered over the years that some people's idea of network load balancing is really round-robin DNS. Let me give you an example of that. Say you have an intranet website running, which all of your users access daily. It makes sense that you would want to provide some redundancy to this system, and so you set up your own two web servers in case one goes down. However, in the case that one goes down, you don't want to require manual cut over steps to fail over to the extra server. You want it to happen automatically. In DNS, it is possible to create two host A records that have the same name but point to a different IP addresses. If server 01 is running on 10.0.0.5 and server 2 is running on 10.0.0.6, you could create two DNS records called intranet, pointing one host record at 10.0.0.5 and the other host at host record 10.0.0.6. This would provide round-robin DNS, but not any real load balancing. Essentially, what happens here is that when the client computer reach out to intranet, DNS will hand them one or the other IP address to connect. DNS doesn't care whether or not that website is actually running. It simply responds with an IP address. So even though you might set this up and it appears to be working flawlessly, because you can see that the clients are connected to both server 01 and server 02, be forewarned, in the event of a server failure, you will have many clients who will still work and many clients who are suddenly getting page cannot be displayed when DNS decides to send them to the IP address of the server that is now offline. Network load balancing is much more intelligent than this. When a node in an MLB array goes down, traffic moving to the shared IP address will only be directed to the node that is still online. We will get to see this for ourselves shortly when we set up NLB on an intranet website of our own. What roles use NLB? Network load balancing is primarily designed for stateless applications. In other words, applications that do not require a long-term memory state or connection status. In a stateless application, each request made from the application could be picked up by server 01 for a while, then swing over to server 02 without interrupting the application. Some applications handle this very well and some do not. Web services IIS definitely benefits the most from the redundancy provided by network load balancing. NLB is pretty easy to configure and provides full redundancy for websites that you have running on your Windows servers without incurring any additional cost. Another role that commonly interacts with NLB is the remote access role. Specifically, direct access can use the Windows inbuilt network load balancing to provide your remote access environment redundancy entry point servers. When setting up direct access to make use of load balancing, it is not immediately obvious that you are using the NLB feature built into the operating system because you configure the load balancing settings from inside the remote access management console rather than the NLB console. When you walk through the remote access management wizards in order to establish load balancing, that remote access console is actually reaching out into the NLB mechanisms within the operating system and configuring it so that its algorithms and transport mechanisms are the pieces being used by direct access in order to split traffic between multiple servers. One of the best parts about using NLB is that you can make changes to the environment without affecting the existing nodes. Want to add a new server into the existing NLB array? No problem. Slide it in without any downtime. Need to remove any server for maintenance? No issues here either. NLB can be stopped on a particular node. In fact, it is actually NIC particular. So you can run different NLB modes on different NICs in a particular server. You can tell NLB to stop on a particular NIC, removing that server from the array for the time being. Even better, if you have a little bit more time before you need to take the server offline, you can issue a drain stop command instead of an immediate stop. This allows the existing network sessions that are currently live on that server to finish cleanly. No new sessions will flow to the NIC that you have drain stopped, and old sessions will evaporate over time. Once all sessions have been dropped from that server, you can yank it and bring it down for maintenance. Virtual dedicated IP addresses. The way that network load balancing uses IP addresses is an important concept to understand. A static IP address on an NIC is referred to as a dedicated IP address, DIP. Those DIPs are unique per NIC, obviously meaning that each server has its own DIP. For example, in my environment, Web 1 is running on DIP address of 10.0.0.40 and my Web 2 server is running at DIP of 10.0.0.41. Each server is hosting the same website on their respective DIP addresses currently. What is important to understand is that when establishing NLB between those two servers, I need to retain the individual DIPs on the boxes, but I will also be creating a brand new IP address that will be shared between the two servers. This IP is called the virtual IP address, VIP. When we walk through the NLB set up shortly, I will be using the IP address of 10.0.0.42 as my VIP, which is so far unused in my network. Here is a quick layout of the IP addresses that are going to be used when setting up my network load balanced website. Web1DIP equals 10.0.0.40. Web2 DIP equals 10.0.0.41. Shared VIP 10.0.0.42. When establishing my DNS record for intranet.contoso.local, which is the name of my website, I will be creating just a single host A record, and it will point at my 10.0.0.42 VIP. NLB modes. Shortly we will find ourselves into the actual configuration of our load balancing, and we'll have a few decisions to make inside the interface. One of the big questions is what NLB mode we want to use. Unicast is chosen by default and is the way that I see most companies set up their NLB, just because it is a default and they never thought about changing it. Let's just take a minute to discuss each available options here to make sure you can choose the one that is the most appropriate for your networking needs. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.